Hi, I'm Wilfred Kaiser of the Sydney Tar Ponds Agency, and I want to welcome you to a virtual tour of the Sydney Tar Ponds and Coke Ovens cleanup. This presentation will give you a broad overview of how the project will work. The site we'll be cleaning up is located in Sydney, Nova Scotia. Contaminated areas include the North Tar Pond, the South Tar Pond, and the Coke Ovens. The entire site is right in the middle of town. 100 years of steel and coke production left more than 1 million tons of contaminated material in Sydney. Our plan is to remove and destroy the worst contaminants while containing the rest within an engineered containment system. Before work can begin on the big cleanup, we must take steps to prevent further environmental damage. A brook running through the coke ovens picks up contaminants and carries them to the tar ponds and Sydney Harbour. The rerouted brook will carry clean water into the South Tar Pond, where it will meet water from the Wash Brook. We're going to isolate these channels from the tar ponds by installing parallel rows of sheet pile or similar barriers. We'll also build a coffer dam to keep contaminants from flowing into Sydney Harbour. Once these initial projects are complete, we'll be ready for the big cleanup. The first step is to dig up the PCB material located here and here. This is how we'll do it. A mechanical dredge will extract the PCB material and place it in covered containers. Then we'll dry the material and move it off-site for high temperature destruction. Next, we're going to stabilize and solidify the material that remains in the tar ponds. Large augers or mixers will drill into the sediment and mix it with Portland cement powder. This will solidify the material to increase its structural strength. And it will also stabilize the contaminants to resist leaching. This process will take place throughout the tar ponds. Finally, we'll cover the stabilized sediments with an engineered cap. This will consist of a barrier of clean fill, followed by layers of drainage material and topsoil. PCB material from the tar ponds will go to a temporary incinerator specially designed to destroy PCBs. Destroying PCBs requires high temperatures and careful attention to detail. The first chamber of the incinerator will burn the solid material at around 1000 degrees Celsius. That's over 1800 degrees Fahrenheit. A second chamber will burn any remaining gases. Next, the exhaust stream will be rapidly cooled to prevent the formation of harmful chemicals known as dioxins and furans. A baghouse will filter out any remaining dust particles. Next, powdered lime will be added to eliminate any acids that may have formed. Finally, powerful fans will disperse the cleaned exhaust from the top of a tall stack. It will take about 3 years to destroy all the PCB material in the tar ponds. Then the temporary incinerator will move on to another job in another community. Back at the coke ovens, a tar-filled pit known as the tar cell needs to be excavated. This tar will be transported off-site for high-temperature destruction in the same temporary incinerator. We'll use land farming, a form of bioremediation on part of the property. will mix bacteria and nutrients into the soil. The bacteria actually eat hydrocarbons, turning them into harmless chemicals. Contaminant levels vary over the rest of the coke oven's property. Some areas will need to be capped. Others will require simple landscaping. Once the cleanup is complete, the entire site will be green. This process will change the face of Sydney, turning ugly industrial wasteland into attractive green space. The cleanup will open exciting possibilities for the future use of these sites. The tar ponds could become playing fields, or urban green space. The coke ovens could become a golf course, or a park. The cleanup could lead to walking trails that begin in Whitney Pier, lead through the coke ovens, along Mugga Creek, around Battery Point to the waterfront, and from there into Wentworth and Rotary Parks. It's a big job, and it's been a long time coming, but the methods we're planning to use have all proven safe and effective at similar sites throughout the world. Now, it's time to get on with the job.